Hi everyone, again. So, so I work as a UI engineer at Flipkart, and today I'll be talking about writing performant UI components. So, if I have to divide performance into two types, I can broadly divide that into two types. One is load time performance, and the other is in-app performance. Now, see, the major focus will be on in-app performance, how to improve it, just to understand about it. But let's first also understand what is load time performance and why it is important. So in the previous talks, we've heard terms like FCP, LCP, or time to interactive. So load time performance is actually what constitutes load time performance is actually these metrics: FCP, LCP, or let's say time to interactive. Now, if you talk about Google as a search engine, okay, it actually lays a lot of emphasis on having a good load time performance. Not only does this, lays a lot of emphasis on this thing, but it actually provides you tools like Lighthouse, where you can actually measure your website score, where it also suggests you areas where you can improve and have a good load time performance. Also, if we even keep that aside, right? So let's say when a user first lands on your website, and let's say your website does not have any content, let's say for the first few seconds, the chances are very high that he is going to bounce off. Okay. Next thing is, even if let's say the content is available, but you are doing a lot of heavy lifting on the UI thread, or you are doing a lot of heavy lifting through JavaScript, then also let's say your website is not interactive for the first few seconds, even if the content is available, then also the chances are high that generally the user is going to bounce off to some other website. Okay. So these matrices and these scores you can calculate through Lighthouse, and a high Lighthouse score is actually important for Google because it actually changes the ranking on of the targeted website. So if you are a website owner or a business owner, it is actually really important to get your website results in the first few results, because generally people do not go to the second or let's say the third page. So it is very crucial to get your website in the first few results. And performance score, load time score, or like even if you call it Lighthouse score, this is one of those aspects which decides the ranking of your website. It is one of the very crucial aspects, but not the only aspect. Okay. Second thing is, let's say if your website is slow, and if that Google concludes that your website is slow, then it says that it is a problem for usability and SEO. Okay, because just like I mentioned, because people generally don't like to wait, users will generally bounce off to another website. Okay, and this is why load time performance plays a crucial role. Now we just talked about load time performance and why it is important, why metrics like FCP, LCP, these things are important, because you want to leave a good impression on the user when he first lands on your website. But an equally important thing is in-app performance. Now, what exactly is in-app performance? So I'll take advertising.flipkart.com as an example. So advertising.flipkart.com is actually a place where brands or sellers, they create their advertisements, and these are the same advertisements that you see on Flipkart's website. These are the same advertisements. So now, see, if we see and I'll take an example. Let's say this is the sale period, okay. Now the thing is, during the sale period, every brand or seller, they want to create more and more advertisement campaigns just to get their advertisements out there on Flipkart, so as to grab more eyeballs and get the uptick in revenue. So if we try to understand the intent of the user here, so the intent of the user is to create more and more advertisement campaigns in the shortest time possible, because they want to get their advertisements out there. Now, let's say your advertisement creation flow involves a lot of visual changes, okay, a lot of visual changes. Then let's say if the experience is janky, or let's say your website or your creation flow freezes here and there every now and then that is a very frustrating experience for the user. Even if your load time performance is good here, but let's say if you're compromising on the in-app performance in such a crucial case, in such an important case, then the user will be frustrated, okay, and then the purpose is defeated, because the purpose here is to get more and more advertisement campaigns out there. And for that, if your flow involves a lot of visual changes, you need to have a good in-app performance. So this is exactly one example where in-app performance plays a major role, okay. But now, see, in-app performance actually, it is what constitutes in-app performance. These are a lot of things like API latencies, your response times, your page-to-page transitions, all these things. Or let's say there is a very complex component that you've built, let's say file upload, where you are doing a lot of heavy lifting on JavaScript. But the focus today will be to talk about components that are visually more complex, and not on API latencies and all of that. But yeah, in-app performance also includes these things, but the focus will be on talking about components that are visually more complex and how can we ensure that they are performant, because we are saying that, okay, our creation flow or our advertisement creation flow, it actually involves a lot of visual changes. So the focus will be on optimizing those UI components. Now, what happens in the pixel to screen pipeline? What happens when a new frame is generated on the website? So these are the steps. Okay, these are actually the not the step, but these are the components that are included in the pixel to screen pipeline. Whatever you write, whatever code you write, how is it finally converted to the pixels or the frame that you see? JavaScript style, layout, paint, and composition. These things are a part of the pixel to screen pipeline. Let's first understand how these things work. So what are these operations and the cost of each operation? Okay, so when you first load the web page, what happens is your HTML is converted to a DOM, and your styles are actually converted to a separate CSS tree. Okay, then what happens is when you load the web page, your HTML is a DOM and your style is converted to a CSS tree, which is combined to form a render tree. Okay, now the render tree is formed. Now what happens is when your render tree is there, every element, every DOM element has now a style associated with it, because you have combined the tree and the tree is now called as a render tree. Now this is the layout part. This is the part where you calculate the geometry of every element, or in other words, where to place the element on the screen. Now this actually depends upon the width, height, or attribute, or properties like top, left. All these things, they determine where the element has to be placed on the screen. This part is called as the layout. Okay. Next thing is, now that you have decided where your elements have to be placed on the screen, the next piece in the pipeline is painting. Painting is actually plotting those pixels, plotting those properties like background color, whatever you define in your CSS, this has to be plotted. Whatever is visual, whatever is visible to the user has to be plotted. Now paint is exactly this part. It is the process of filling in the pixels. Okay, and now the thing is, every browser has its own rendering engine. Google Chrome will have its own rendering engine, Firefox will have its own rendering engine. But the thing is, so the painting process actually depends upon the rendering engine also, because they use some auxiliary data structures which depends upon the rendering engine. Okay, now what happens is, for every element there is a style associated. You define properties like color, background color, or let's say any other property like text align. Now what happens is, these elements are actually painted into different layers. They are actually painted into different or multiple layers. Now this information of painting or plotting those pixels into multiple layers is passed on to the compositor. Now compositor, its job is actually to combine those layers in the correct order. Now this actually is the most powerful piece in the pipeline, compositor. Why? Because these three things, layout or painting, these things actually happen in the main thread of the rendering process. So rendering is a process in a browser, and these things actually they don't have a separate thread for it. They happen in the main thread of the rendering process, layout or paint. But compositor, okay, the thing to note here is that compositor has its own separate thread, and the most important thing or the highlight is that compositor can access your GPU. Okay, so it can access your GPU and it is faster. Now the thing is, there are some properties like translate, scale, rotate, which the compositor is capable of handling on its own. It does not require painting or layout. So let's consider an example. Let's say you write some JavaScript code to add a class to an element. Okay, you write some JavaScript code, you add a class to that element. Now what will happen is, let's say in that class you are changing the margin, let's say margin top of that element. Now what will happen is, layout part will trigger again, because now you change the margin top of the container. Now the geometry of that element, its siblings, and let's say its children also will have to be calculated again. The geometry of that particular portion that is invalidated now has to be calculated again. So now the layout part comes in here. Now this is the inevitable part. Okay, even if you have changing the layout, but the paint part will also be triggered again. If you trigger the layout part, this in turn triggers the paint part also. Okay, and that then in turn it will trigger the compositor, because it has to combine the layers in the correct format. Now let's take another example. Let's say through the same JavaScript code, you add a class to your element, but that class changes only the background color. Okay, now background color is a visual property. It does not require any geometry or does not require any position, let's say position change on the website. Now layout will not kick in, because just like I said, geometry change or the positioning change is not required here. Painting will just change the background color. Painting would be triggered, and then in turn it will trigger the compositor part. But just like I mentioned, there are some properties like opacity, translate, scaling, which will even not trigger these parts. Okay, layout or paint, it will directly go to the compositor. Now why is it important to ignore these operations wherever we can ignore them? The reason is that most devices these days are 60 FPS, 60 frames per second. So every frame, if you see, every frame has roughly 16 milliseconds to get itself ready. And if the frame is not ready, the frame will be dropped. Okay, browser is going to drop your frame. And let's say if you want to accelerate this process, what we ideally want to do is we want to eliminate the pieces of the pipeline wherever we can. Okay, there are some parts which are inevitable. Let's say JavaScript you cannot ignore because you are making visual changes or you are creating a new frame through JavaScript when you trigger a change. These things you cannot ignore, but what definitely we can ignore is layout, painting, and or maybe what we can do is we can delegate the work to the most powerful piece of this pipeline, which is compositor, wherever we can. Okay. However, there will be some cases where you would not be able to ignore these parts, but wherever we can, we should, because we want to accelerate the process of creating a new frame. Okay. So now what we are going to do is I am going to show you two examples, two components where we are going to use the same ground rules and we'll see how performant they are. So this is actually a color picker component. So if you use the cursor to hover over the gradient, then you will see the X value here and you will see the corresponding RGB values there. Okay, so what I'll do is I'll turn on paint flashing, which will tell you what parts of this component are being painted when I make any changes, which means when I create a new frame. I'll turn on paint flashing and I will also turn on the FPS meter. Okay, so if I move this, okay, you see that there is a paint flashing green highlight here and not the RGB values. Why? Because see, this is a part we cannot ignore. This is a visual change. Whenever you change something here, these values are visible to the user, they have to be changed. Okay, so this part is being painted again and again when you change. So that is why you see a paint flashing highlight here. Similarly for this color, because this is a visual change, you have to change the, let's say, the background color of this box. Now, but if you notice, okay, you do not see the paint flashing on this cursor. This circular cursor, you do not see any paint flashing here. Why? The reason is we are using, just like I mentioned, there are properties that the compositor is capable of handling on its own, like translate. So when you actually move it, we are actually translating it. We are not changing top, left or anything which triggers the geometry, which triggers the layout. Okay, so this is just triggering the compositor part and compositor can handle it. That is why the reason is that you do not see a paint flashing there. Okay, next thing is, if you notice the FPS meter when I move this around, if you notice the FPS meter, if not 60, but it is close to 60 FPS, okay. Next thing is, if I move the slider, you see paint flashing on the slider. Although I'm using translate here, this is being moved through translate, which the compositor can handle, but it is being painted. Why? Because I'm changing the background color of it. I mean, this part we cannot ignore because it has to be painted again. Okay, this is a visual change, as and when you move the slider's background color has to change. Okay. Sorry? No, circle, we are just picking, so this is actually a canvas. We are just picking the pixels from that canvas. I'll explain that in another example. So this actually brings me to the eyedropper. Okay. So what it does is, it zooms in this part. Okay. Now, when I zoomed in part, when I click on it, it just gives you the color value there. So now what we are using here is, when you click on this eyedropper, what happens is, we take a snapshot on the screen. So there we are using a tool called HTML to canvas. When you click on it, we take the snapshot of the entire screen. Okay, we take the snapshot on the entire screen, and let's say when you move this, so this actually is also, this circle is actually also a canvas. Now what happens is, when you move this around, we take the position. Okay, let's say we take the diameter of the circle and we get the pixels. Okay, we get the pixels out of the screenshot that you've taken earlier. Okay, let's say I move it here. We have one canvas which is the screenshot which we had created when you clicked on the eyedropper. The second thing is, this is also a canvas. This circle is also a canvas. We take the position of this, let's say the circular, we take the circular diameter into account. We get the pixels from the canvas, and what you see zoomed in is actually a scaled 2x version of those pixels. We just plot the pixels on this. Okay, just plot the pixels on this and scale it to 2x using the standard CSS properties, and that is why you see the zoomed in version. Okay. Now the thing is, this is being painted. This circle is being painted because we are changing the pixels on this canvas. This circle is also a canvas. We are changing the pixels on the canvas. That is why it has to be painted again. Whereas this cursor, this one, we are only getting the position here, and I suppose we are using it somewhere down the hierarchy. We get the position here, and then from this gradient, this background is actually also a canvas. So we get the position here, and we get the pixels at that position, which we change here, which we use to calculate the hex value and then the RGB values. Okay. Now next thing, also a very important thing here, is I will show you the layers. What are the layers that are painted here? If you see here, right, the slider, this thing has its own separate layer. Why? The reason is that we are using a property called as will change. Maybe in fact I'll show you that. We are using a property called will change. So will change is a property that beforehand tells the compositor that this property sometime is going to change in the future. So what the compositor does, it plots it, or it maintains a separate layer for that particular component. So this is why, this is precisely the reason. Maybe if I try to remove it and reload, the layer should not be there. So this is a way to optimize further. In a way you can tell the compositor, or you can inform the compositor beforehand that this is going to change, this is bound to change. Okay. So now if you look at the layers, the slider layer, this layer is gone. Because we have not used the will change property, compositor is not creating a separate layer for this. So the layer is gone. Okay, but having said that, will change should be used, I mean, very, very carefully, because browsers are out of the box very optimized. You should only use this property when you're very, very sure. And also we don't want to overload although your compositor can utilize your GPU, but the idea is not to overload it. Okay, because the browser itself is very optimized to do things. Next, let's come to a slightly more complex example, which is a slider component. Okay. Same, I'll turn on the paint flashing for this also. And the FPS meter. Now if you notice the FPS meter, still not 60 FPS, but it is very, very close to 60 FPS. Now the thing that you see on the screen is, when I move the slider again, the slider is not being painted again. You see the paint flashing on the tooltip. Why? Because tooltip, see, this is a visual property, I have to change the number as you slide. Okay, so this has to be painted again, this cannot be ignored. But the slider, again, we are using translate, which is a compositor only property. That is the reason it is not being painted again. The compositor enough is capable to handle this. Okay, layout is not triggered, paint is not triggered, the compositor can handle this on its own, and this applies to every slider here. But now the thing to note here is, and yeah, if I show you the layers again, I think all of this they have their own separate layers. So you see three small squares here, which are these layers actually. These sliders have their own layer because I have added a will change to these sliders. Now the thing is, this color that you see, okay, slightly darker red here, okay, and the color variants that you see here, the first thing when I see this component comes to my mind is, how can I create this? Let's say there are 4 divisions and there are 4 colors. How can I create? The first thing that comes to my mind is, I can add 4 divs, and every div can have its own background color. But the important thing to note here is, this is exactly not that. This is actually a linear gradient. Okay, I could have added 4 divs and each div can have its own background, but this is not that. This is actually a linear gradient. Why? Because wherever we can, we want to remove the extra DOM nodes. Okay, the idea here is to remove the extra DOM nodes. Why? Because see, if you have less number of DOM nodes, that it automatically means, you know, less load on layout and painting. Okay, still not painting, but yeah, less load on the layout. Okay, and if I have to show you if I inspect it and show you the gradient, this is actually not a, just give me a second. See, this color that you see, they are actually not divs placed in flex. Okay, we could have done that, we could have placed them in flex, we could have applied background color to each div, but instead the better idea here is to add a linear gradient, because we are saving on the DOM nodes. Okay, we are saving on the DOM nodes here. Secondly, an interesting thing to note here is when I move the slider, or let's say when I move the slider, technically when it is in the hands of the user can move the slider, you don't know at what pace he's going to move the sliders. Okay, so instead of changing the state in this, okay, we are not changing the state here, by the way, using set state to get these values. What we are doing here is we are utilizing, we are changing the state, but just not through set state. What we are utilizing is refs. We are utilizing refs here. Okay, now as and when you move this through the position of the slider, we do a bit of calculation here and there, and then we calculate what should be the value when, let's say you are not moving the mouse anymore. Okay, or let's say when the mouse down event is fired, we calculate the value. Then what happens is, maybe I'll show you the tooltip. I will force state a hover on this. Yes, so just like I said, we are not changing the state here, because technically the user can move it at any pace, and it would not be a good idea to change the state on every, let's say on every movement of the slider. Now instead what we are doing we are calculating the values on the fly. We are storing it in the refs, which is passed on to the child component, which are these sliders. Okay, now if you have a look at the tooltip, now the thing here to notice, tooltip is also not a DOM node. Tooltip is also here a pseudo element. So in kind of way we are saving on the DOM nodes here also. Okay, so it is actually a pseudo selector. This is also not a DOM node. Now if you see the content, right, if you notice the content here, this one, the content says attribute data tooltip label. So what we are doing is we are calculating the values on the fly. We are calculating from the position of the slider, we are calculating the values on the fly, setting it on the ref, and then setting it on the ref and also on the attribute of the HTML element. Then what happens is, in style components there is a way in which you can pick those attributes. For example, this is the attribute. Okay, this is exactly the value that you see on the tooltip. This is the attribute. That's exactly the value that you see on the tooltip. And in style components there is actually a way where you can read all these attributes. So what we are doing is, instead of updating the state through set state, we are updating the values on the fly, and for rendering them we are making use of this attribute which we have set on the fly. Okay, so the idea here, and also just like I mentioned, we are not adding any DOM nodes. This is just the pseudo selector. Okay, before and after. So the idea, and let's say the conclusion here is that even if we follow the same ground rules, we have the tooling at hand, and if we follow the same ground rules, or maybe remove the load from the, let's say the renderer process, and delegate it wherever possible, if not 60 FPS, let's say very close to 60 FPS, the UI, the UI components can be performant. Okay, because the tooling is available. See, everything is available then and there. Okay, we just have to follow the same ground rules, and maybe even if we are delegating a lot of work on JavaScript, we should first see if that can be done alone through CSS. Okay, so these things we can keep in mind, and if you follow these things, components can be visually, complex elements can be very performant. Yeah, so thank you. That was my time, and I would love to connect with you all. Thank you.